So in today's video, I'm going to talk about Kotlin classes and objects. How do they differ from Java, and like what are the useful things they provide? So let's get started. So let's start first with constructors. So whenever we have a class, the first thing we'll do is like maybe just create instance of it. So in Java, if we have to write a constructor, we would write like class, and then the the constructor would be the same name of the class name, right? And then we will pass like the arguments and all to the constructor. But in Kotlin, we could just be like everything could be just done in one line, and you just add the constructor after the class name, and then you just pass the arguments which you want to the pass to the primary constructor. You could also add like visibility variables or annotations in front of the constructor. So in that case, all of those kind of annotations and all or visibility modifiers are applied. We could skip the constructor keyword if the class just has one constructor, and that's the default constructor that we want to take. Like if we take in this case, this is a class, so there is no constructor needed because this is the only default constructor that we have, and we are not modifying the visibility or we don't need any annotation and all. So other is init block. So in Java, we would just declare blocks which were initialization blocks, but in Kotlin, we would specifically mark them as init block. So the init block would run after the constructor. We could also declare the fields uh, or the properties within the constructor itself. So we can have like val and then the property, and those could be so that like whenever you're creating a new instance, they would be just initialized right away. So this reduces the amount of code that we have to write. So like now it's written just in one line. In Java, it would be typically taking like five or six, at least 5 or 6 lines. So here we see a constructor and like a class with two constructors. This is the primary constructor and this is the secondary constructor. So in the secondary constructor, the first thing we'll have to do is we need to call the primary constructor, and that is done by calling this, and we pass the argument. So we call the primary constructor in this case. So next is inheritance. So to inherit, like by default in Kotlin, all the classes, fields, and functions, they are marked as final. So if any of the classes needs to extend it, we need to declare like explicitly mark them as open. Like in this case, we see the class is explicitly marked as open. The same needs to be done for the properties and also the methods, right? So here, like this method, we don't need to override, so we are not declaring that as open. But if we need to extend the class, we have to mark this as open, and the way to extend it would be like we don't write extends keyword. We just use a colon and add the name of the superclass. So here, like vertex count is overridden. So and in Java, override keyword is not mandatory, but Kotlin has made it mandatory that we need to always mention whenever we are overriding it. So again, few things to keep in mind. One is whenever we need to extend the superclass things needs to declare the class properties or functions as open, and whoever is extending that class, they need to use override keyword. So interfaces are very similar to Java. So we could just declare an interface like the way we did in Java, but like instead of using extends when we are extending one interface from other, we just use a colon, just like we did it in the case of classes. And we could also have a class that extends the interface, and the class could straight away override the properties that were declared in the interface. Right? So our interface, like the first one had name, and the second had like first name and last name. So the class that has employee is basically implementing these properties and all. Next is anonymous classes. So In Java, we would use a new keyword now. So in Kotlin, there is no concept of new keyword. All we do is like write the class name, pass the arguments, and uh, we get a new instance of that class. So in this case, whenever we're creating an anonymous class or anonymous instance, we use an object keyword, and then we say that what type of anonymous class are we creating. So this is mouse adapter in this case, and this is the function that we override inside mouse adapter, and this is the variable which we get of this anonymous class. So this is the sorry, this is the object that we get. So we could create object by combining two classes or a class and interface, just like we would do it in Java. So if we have to write a singleton in Java, we have to write a lot of code, right? Like maybe write a private constructor and all, and then return a factory method. So in Kotlin, it's very similar. It's very simple. All you have to do is just call object and write the name of the singleton that you want to create. And the singletons could extend from other singletons like or other objects, or like so in this case we have override function and we're extending from this mouse adapter which had that function. uh, so there's another concept of companion object. This is again like based on the companion objects that we use in Scala. So this provides companion objects, like whenever we're getting started with it, we don't get to know like how useful it is. So basically this structures the code very nicely. So like whatever whatever methods you have that operate on the properties and all would go into the class, but whatever pure functions you have, they could go into the object, the companion object. So and also all the factory methods would go into the companion object. So and then if you want to create an instance of that class using the factory method, all you have to say is just name of the class dot create, which is this function. So again, like, so companion object is nothing, it's just like an object which we saw here, right? But uh, and the way to declare an object, a companion object, which is basically it's accompanying the class, so it declares the stuff that is related to a class, right? So we create a class, and within the class we declare companion and object. We use these keywords. We could give a name which is optional here, which is maybe just to make like just for like coordinate and all, but it is not needed. And then we could say that if the companion object extends or implements something. So in this case, it is implementing this interface, and so we override the create method. Now all the methods that are within the companion object can be called by my class, which is this class dot and the method straight away. This is very similar to calling the static methods, but there are a lot of benefits that we get from objects as compared to like static modifiers and all which we have in Java. Next is properties and getters and setters. So if we to declare mutable properties, like the properties that can change, we use var, and to declare final properties like which do not change, we would use val. And the getters and setters could be just mentioned by saying get and declaring it like this. So this will return the value, and we could just set the values by using a setter. Mostly we would like this is not used very frequently, getter and setter, unless we're really modifying or doing any validation and all. Setters are sometimes used whenever we have dependency injection. In that case, all we have to do is if this value gets set by some framework, so we declare the field here and then we say set, and then we say at the rate inject whatever, so that the value could be injected. There is also concept of compile time constants. So on the compile time only, they would be substituted. So we could declare compile time constants by calling const val and declaring those constants. So the last feature which I'll cover for today is single abstract methods like interfaces. So this is very similar to single abstract method interfaces in Java, or like we call functional interfaces, where the interface just has one method. So if you see this interface, which is in predicate, it just has one method except. This allows us to use these interfaces as a lambda expression and all. So we could very easily create like whether it's a is even type of in predicate, right? So which accepts something. I would just say that whether it's is even or not. So the way to implement it, so so basically is even is an implementation of in predicate which would have except method in it. So it's done in a very concise way. So this is what we are implementing, and function except refers to this, which is it takes an int, which is referred to as it. It would do a mod by 2, and will check if it's 0. Right. So this is the body. Right. So all of this thing, like which is fun except or this does not need to be written. So we understand that it would be represented by it, and this is the body for for the only function that we have, right? So there are no multiple functions; it's just one function, and this is very similar to SAM interfaces in Java, or like function interfaces in Java. So here we see like where we are just calling is even dot except, right? So is even, we are not declaring any except here. So since we are implementing it, so we call dot except and we pass the 7. So which would be of course printing is false. So this is the part 1 of classes and objects in Kotlin, and I'll be recording the next video tomorrow.